Hey everyone, so today we're going to do notes again, and we're still working on section 1.1. We're taking it kind of slow, but hopefully you guys are getting the hang of this. So in today's section, we're going to cover segment addition. Okay, so go ahead and write that down. That's the title. And here we have segment addition, and kind of it's defined as if we have 3 points, A, B, and C, and if they're all collinear and B is between A, C, then they have this relationship here, where you have the segment AB and then BC. If you add those up, it equals the whole thing. Okay, so if you look, AB is here, and then BC is here, so that's AB plus BC, and then obviously if you add them up, or if you put them together, it equals the entire length, which is AC. Okay, seems pretty easy to me, makes sense. Let's move on. Midpoint, that's just a point on a segment that is the same distance from the endpoints. Okay, so you can think of it as a halfway mark or the middle. That's the midpoint. So here's an example of a midpoint. M is the midpoint of QR because it's in the middle, and the distance to Q is 4 inches, and the distance to R is 4 inches. Okay, so again, it's the same distance from each endpoint. Okay. Let me try to autofocus that dude. And move on. Bisect means to divide into two congruent segments or two equal segments. Maybe something you're more familiar. Cut in half, right? If you cut something in half, you're cutting it into two equal parts. So that's what bisect means, okay? Divide into two congruent segments. But usually, like a segment, they'll say a segment is bisected. That means it's cut into two equal smaller segments, right? And then here's just some notation. Let me lower it or raise it, whatever. Is equal to, we use equal to or is equal to when we're dealing with numbers, like actual lengths. Okay, see here I put use with numbers, and then see here I have like 32 or 3.2 centimeters is equal to 3.2 centimeters. And if we're dealing with the notation, you don't use the line segment on top, even though it's referring. AC is like the reference is the segment AC, but when you have just AC with no line on top, you're talking about the actual measurement and not the actual segment. It's kind of nitpicky in geometry, and well, you'll see. You'll see it displayed different ways, and that's why. And then this one is congruent to. We use congruent to when we're talking about figures, segments, triangles, angles. Okay, and then the two different symbols you guys all have seen equal to. Equal to is that guy. It's just two lines, right? And then congruent to may be new to you, but it's two lines with the squiggly on top. Okay, and again, if you're not talking about actual measurements, actual numbers, we would, and referring to more like the object, you would use congruent to. So AC is congruent to DC, right? There's no measurements here, but I know they're the same because we're saying congruent. And then there's some marks that we use in geometry to show segments are congruent. They're just little hash marks that we put on different either sides or segments or angles. You'll see this when we come up with angles in the next section. We put marks on them to show that they're the same length or same measure. See here where it says AC is congruent to DC? On the diagram I could do this. And these two little hash marks, or what these two little lines, they tell me that this line is the same length as this line. It's congruent to. Okay, so here I put use marks, like these marks here, to show congruent segments. So I know MN, which is 6, is equal to NP. So that means the segments are congruent. Okay, so that's all definitions. Let's turn this guy over and do some examples. So here we have some examples. I'll go ahead and just leave the whole thing up. So here it says, name the midpoint and the segment it bisects. Okay, that seems pretty straightforward. The midpoint is Q, and the segment it's bisecting is RP. Okay, Q is in the middle of RP. Draw and mark a figure in which M is the midpoint of ST. So again, kind of put down a segment, ST, kind of find out where the middle is, M, and then to mark it, that's how we mark it. So I know M is the midpoint of ST because of these marks. Okay, pretty straightforward. And then I'm going to use the segment addition. It's technically a postulate, but segment addition to do these last ones. Okay, so here we have a segment, AB. It's broken up into two segments. Okay, so it says write the segment addition relationship, then solve. AC is equal to 5, CB is equal to 12. Find AB. I know this piece plus this other piece equals the entire length from A to B. That's the first part. Write the segment addition relationship. I wrote it. Now I'm going to substitute what I know to figure out what's left over. AC is 5, so I put a 5 here. CB is 12. AB I don't know. So then I can just add 5 plus 12. That's 17. There you go. We figured out what AB is. AB is 17. Okay. So I'm going to do the same thing with this one. I know this smaller piece plus this larger one, CB, is equal to the entire thing, AB. Then I'm going to come over here and figure out what I know. AB is 20, so I put 20 on this side, and CB is 15. Now the one I don't know is AC. Okay. So then I just need to figure out what AC is. Well, based on these numbers, hopefully you don't have to do too much. But AC, I would think you would just say, oh, AC is 5, because 5 plus 15 is 20. But technically, right, if we're using algebra to solve this, subtract 15 to both sides, and then when you do that, you're left with AC here. 15 minus 15 is 0. Bring down your equal sign, and then 20 minus 15 is 5. And there you go, AC is 5. Okay. Maybe I should put my answer over here. And then the last example I have, same idea, although it involves a little bit more algebra. So I'm going to write TZ plus ZW equals the entire thing, TW. And those are the pieces that I have in here. TZ, ZW, and TW. So TZ is 2x, ZW is 3, and then TW is 15. Find x. Okay. I'm trying to lower this. So I put in my values. Now I want to solve for x. So this is just a solving a two-step equation from algebra. If we want to get x by itself, the first thing I need to do is get rid of this number. Since it says plus 3, I'm going to write minus 3 to both sides. All right, that's 0. Then you have 2x equals 12. And then I did run out of room here. But the next step would be divided by 2, divided by 2. Right? And then the times 2 and divided by 2, you get 1. And then that's x equals 6. Again, I ran out of space there, but there you go, x equals 6. Here, 2 times x, to get the x by itself, you need to divide it by 2. And then again, what you do to one side, you do to the other side. 12 divided by 2 is 6. Okay, that's the notes. Make sure you get them all. Stop, rewind, and pause wherever you need to copy. That's it for today.